Good evening, good afternoon, and good morning, everyone. Um, I'm going to kick things off on time. I have a feeling we might have a few more people joining us as we go through the presentation. Um, Firstly, apologies from our managing director, Anupriya Balikai. She was hoping to do the introductions as she normally does on these webinars. However, she's currently traveling in Belgium, and it seems like the internet there isn't as good and strong as it should be. So hopefully we can, in the Q&A session at the end of the presentation, we can hopefully get some input from Anu and our technical director as well. Kicking off the fourth webinar in the series. For those of you that are new, we hold the webinar once a month, and we're in the fourth one, exploring different items in the world of vision and quality control. And I think really the topic today is 3D, three-dimensional imaging, perception, analysis, and how that can help you on the production line or whatever the challenge you might be working on. We're very much a company focused on machine vision, machine learning, and combining that all for real-time processing and quality control. 3D is actually quite a big topic in the world of vision at the moment, and has been for quite some time as well. So my name's Dr. Joni Ronkainen, Sales Director at Spookfish Innovations. I'm based out of Bristol in the UK. And I will be handing over to my colleague Piyush Singhi, who's based out in New York in the US, a new territory for us. And I'm sure there's plenty of people on the call, on the video call today from Bangalore, where our headquarters are, and I'm sure lots of other people from India. So moving on. So the depth ambiguity. I'm sure most of you on the call today will have seen images like this. I know in India, the Taj Mahal is another good one. Fun spot for taking photos like this. I know my wife and I took similar photos in the San Pedro de Atacama Desert in northern Chile. So I'm sure nothing new to people. But I think the point of the image is this, the perception of the image in a 2D image, like what is presented on the slide, does have its limitations. Our brain is incredibly powerful, but if it's unaware of the context and without its 3D vision or stereoscopic view, as we as humans have with two eyes, it can construct false meaning and cause misleading information. So I'm sure most of you will know that the lady isn't hugging the Eiffel Tower. Well, definitely not the Eiffel Tower, Leaning Tower of Pisa. But when we introduce context into the image, you get more complete information of what is actually going on. So things start to fall into place in the image when you can see, the people around are standing and probably taking very similar photos. Now, this is obviously not very relevant to people in the pharma or food or metal or sports industries, as I'm sure most of you on the call today are from. But I think hopefully the point is, we're going to explore the inclusion of more than two dimensions when perceiving and processing information gathered from images, and how this helps towards better context and quality control, which I know will be super important to most people on the call today. So this month's webinar, we always have a theme. All of our products at Spookfish are named after fish, and we've decided that even our presentations are going to have a theme. So the theme this month is Javelin Spookfish. Very special for us, given it's behind the Spookfish name of the company as well. But the reason we've chosen this is, the fish has mirrors in its eyes to maximize its view. And that's exactly what we're exploring today on the webinar. So I think we've seen why depth is important with with the sort of silly example from Italy. But we're going to go over a few methods and hardware options to estimate depth in real time for different applications. We're then going to understand stereo vision, and if you're not aware, that is how we as humans perceive depth through stereo vision, given we have two eyes. And then finally on the presentation, we're going to look at other methods to include more information in a single image using optics. And some of that work, I think you'll find quite interesting and fascinating. So before I hand over to Piyush, just very briefly touching on Spookfish. We've been around since 2015, so a while now. And HQ's in Bangalore, as I'm sure most of you will know, and then myself in Bristol and Piyush in New York. We've got respective offices for North America and Europe. We estimate that we've inspected over $80 billion worth of products. Now, obviously, a lot of pharma guys on the call today, a lot of valuable items going through your production lines on a daily basis. And we think, we've really helped save companies a significant amount of money through the quality control processes that we put into place. One thing I do want to highlight is, we're very much aimed at 100% online or inline inspection, whichever you prefer to call it. And we don't want to be introducing processes on the production line that are going to give you 100% inspection, but slow the throughput down. So we're very much about zero reduction in throughput, but 100% inspection of products. On average, our systems are about 8 weeks to implement. Obviously, it depends on the size and scale of the challenge. We, on one of our other webinars, have explored seeing beyond the visible, so in infrared or other spectra. I don't think we're going to really touch upon those today, but if anyone's got any applications outside of the visible spectrum, we'd love to hear about them. Fast, accurate, and reliable is sort of what we're striving for with our machines. And for those of you that aren't aware, we are very much experts in AI and machine learning. And that's, a real core competence of the business, and one of the reasons why I actually joined myself a few years ago. So last slide from me, and I won't dwell on this, is, why Spookfish? On the left-hand side, you can see a lot of the items that we work on. So I've just mentioned artificial intelligence and machine learning as one. Automation is highly important, and the design behind that. Hopefully some of the applications we'll be sharing from the world of pharma and money will show that, quite a bit of design goes into these projects. We're pretty much exploring visible spectrum today. We do work in other spectra, as I mentioned just now, but we're not really going to touch upon them on this presentation today. And then on the right-hand side, most of our work is around quality control, inspection and application, whether it be in the primary or secondary packaging or wherever. I know seal inspection is on here. That's something that's one of our flagship products at the moment. So if anyone's doing any heat sealing on their lines, we'd love to help you with the quality control of that. But I think without further ado, I'm going to hand over to Piyush in the US. And one key thing is we always really enjoy Q&A at the end of the presentation. So hopefully there'll be some good questions at the end of the presentation. Piyush, over to you, and I'm going to stop presenting now.
All right. Thanks so much, Uni. Let me know when you guys are able to see my screen.
That's good to go, Piyush.
All right. Awesome. Okay. Thanks so much for everyone to who joined the webinar. Again, we'll be focusing on the different types of vision and how we kind of tie it all together when we think about our products, and incorporating that in the production lines to help with quality control and all, right? So this particular example that you're looking at right now is basically how structured light is actually being used to identify or to be able to create some sort of like a 3D imaging kind of thing, right? And the way the whole process essentially works is that when you look at this, how the light is actually getting distorted when it's being cast on like a three-dimensional object. So by measuring this shape of the distortion, we are actually able to identify the depth, and not only the depth, but also the actual shape of the object as well, right? And the way to kind of like simply think about this is that when we are actually having the light being projected on the actual object, based on the three-dimensional space that's actually being occupied by that object, there are certain set of points which are actually going to be closer, resulting in smaller squares, and then based on those shapes, we are essentially able to kind of identify what the overall object shape actually looks like. And this concept is actually built into 3D scanners, and they operate at like very high accuracies as well. And complex shapes can be identified using this process within a matter of like seconds, or in certain cases minutes. But it's still a pretty useful, pretty accurate tool that helps you understand the shape of the object, helps you get like depth estimation and all of that. Okay. Now, taking this a little bit further, what we are also able to do is not just the actual shape of the objects, but even like very minute like undulations on like flat surfaces and all can be actually spotted using a more coarse pattern of like a structured light, as shown in this particular example. Now, of course, I mean, we've kind of like highlighted this using like a black marker to kind of like indicate where the actual defects are. But yeah, I mean, the light spectrum can essentially identify any sort of like undulations, any sort of like defects on its own, just by the way the whole camera system and the supporting software actually works. Which is pretty important because if any sort of machining issues are to be identified, then a system like this could really help you from like a quality control perspective in a very, very reliable manner. All right. So moving on, how do we actually incorporate this within our products? So again, we have our solution called Microps, which essentially uses structured light for high speed and high accuracy measurement of thickness, specifically around like currency coins or tablets that are getting packed into blisters. So now the thickness measurement systems are actually placed seamlessly in line with your production line. As Uni pointed out, we really don't want to hamper anything that impacts the production line or slows it down in any way. So again, we can kind of measure thicknesses for up to 50 coins per second. Now, one thing to keep in mind is that there are two ways, the measurement can actually be done, right? I mean, either you can actually have the actual products, like the coins, being passed through the laser beam, where the camera is actually stationary, or the other approach could be that the product remains stationary while the camera moves. Now, in the second approach, obviously, if the camera keeps on moving, there's the whole concept of actually moving the product, after the inspection is done, which could technically slow down the whole process. Which is where we kind of like took the approach of keeping the camera stationary, and the products, the coins essentially move through the production line. And of course, I mean, as we are moving the target across the laser line, it basically creates multiple height profiles that we essentially combine to get like a 3D profile image, which is what you see on the right hand side. So you have the inputs, you process it through the laser system, and then based on that, we are able to get the height profile and a 3D profile associated with it. So I just kind of show you how the machine actually works in action. So you have the blue line laser, and yes, that's how you see the whole process kind of just working, and that's how we are able to create that 3D profile as well. Moving on, so the next one is basically the identifying or even measuring like minute details. So in this particular example, you see there's an orifice in the bilayered template or tablet, which is actually getting measured using the laser profiling, right? So over here also, if you look on the right side, based on um, the laser using the structured light, we are essentially able to find or indicate that, okay, you know what, there's an orifice, and if it kind of like matches up with the parameters that we have essentially set up, is to be accurate. And these are fairly precise. I mean, they can essentially measure things up to microns at that level. So it's pretty precise, and a lot of our customers actually, use these systems to kind of help them with these minor, not minor, but these minor components within the actual tablets and all, but are fairly important and integral to their production lines. Moving on, so we've looked at the structured light so far. So now I'm going to move on to the stereo vision, which is mostly around how we humans actually look at things. So just to kind of give you guys like a quick walkthrough of how we actually look at things with two eyes. So again, you have two cameras, camera A, camera B, and then if you have the objects placed right in the middle, camera A kind of perceives it a little bit differently versus camera B. And again, I mean, there's a technical term for that, parallax. So anyone who's studied physics would probably know this. But yeah, so this basically allows us to create like a three-dimensional object in our heads as well, because our eyes kind of work as those camera A and camera B. And then what ends up happening is, these multiple cameras are essentially talking to each other. In some sense, our brain, our eyes are talking to each other via our brain, and our brains basically creates that three-dimensional object in our head to be able to perceive this in the proper manner that we do. Right. So similarly, the two cameras observe a common point in the scene, and then based on the triangulation methodology, they are able to identify, the actual three-dimensional spacing of these objects as well. And obviously, I mean, this helps with the accurate localization and measurements in large scenes as well, right? So what's the use case for something like this, right? So specifically, if you think about the sophistication that we now see in 3D animation movies, or your video games and all of that, where all the objects and the animation are like so lifelike and have that three-dimensional component associated with it. So over there, a lot of this is actually being used, where infrared emitters are actually placed at various points in the human body. And as the humans move, the motion is captured by detecting and triangulating the infrared emitters in the three-dimensional space. Now, of course, I mean, the captured point cloud is then retargeted to a CGI system, which helps create lifelike animations, which we typically see in like Disney movies or Pixar movies, in a wide variety of formats. Not just that, even in like gaming industry, when you play Call of Duty, I mean, obviously you might have seen and be impressed by the graphics, the level of sophistication that they have over there. Okay. Moving on, so again, at Spookfish, we've kind of done our own simulations, so where we actually deployed 4 cameras working in conjunction with each other, and we have the software built on top of it, which basically links the images from each of these 4 cameras, and then based on that, it's essentially able to accurately triangulate and track all the people in the room in real time, using the same stereo vision concepts that we kind of just looked at a little bit earlier. So again, very cool. just based on these cameras, we are able to identify where people are. And again, I mean, this is a simplistic implementation, but as we kind of continue to evolve our products, we see a lot more sophisticated elements in place, especially from like a quality control perspective. Now, again, we'll kind of like look at some options that we have in the market in terms of consumer 3D cameras. So obviously, the technology continues to get cheaper and much more sophisticated. So some of the camera manufacturers have actually taken advantage of these stereo vision and the structured light, and kind of like combined them all into one product for their specific use cases, right? So Microsoft basically implemented this in their Connect platform, and now it's basically a part of their standard offering as a part of Xbox Series for gaming, right? So whenever you're playing any games or anything like that, I mean, the Xbox Connect kind of looks at the person, and they're able to identify the motion and kind of yeah, translate that back into the actual games as well, which is kind of like cool. Because you're really getting to be a part of the actual game as well, which is really interesting. Now, Intel's RealSense cameras are also kind of similar in that way. On the other side, I mean, one of the other use cases is basically LiDARs. So they also use similar kind of like concepts. And again, we all know LiDARs are actually very, you know, uh, useful from like a self-driving car technology perspective. Tesla has been investing a lot in that. So again, I mean, that's something that we see a lot of people kind of moving forward with as well. So this technology has a lot of teeth, and it has a lot of implementations which are in progress. So we envision this kind of continuing to get better and better as time goes on. Now, the bottom picture that you see, it's basically a depth map. So again, you see the different color coding to kind of understand, the closer ones at the bottom, and has a different color parameter associated with it, while the one further beyond has a different color parameter. And as you can see, the human being is actually standing somewhere in the middle. So the color combination or the color coding for that is a little bit different, similar to where the person is actually standing. It kind of takes that base as such. So again, the IR structured light pattern, it's basically able to identify the actual depth from that perspective. And of course, it doesn't really interfere with the human visible spectrum, because this is essentially using the IR component, the IR structured light. Okay. Now, so we've kind of looked at the use cases where the actual objects are in the path of the camera, right? So in a lot of other situations, what we have seen is that actually having multiple cameras can be pretty expensive. So what are some of the other solutions where we can essentially have a limited set of hardware, but some other creative methodologies to kind of look at the object from multiple angles, or look at multiple objects at the same time, right? And over there, of course, we are using technologies, or not technologies, but components like prisms and mirrors to be able to split the light in different directions and be able to look at the object in the appropriate fashion. So again, in this particular example, you see how there are two objects, and based on the prism, the light gets reflected from both the objects, and it's actually feeding into the camera in this particular case, right? So yeah, this is essentially how we would use the same set of resources, but increase the throughput in a much more optimized fashion, kind of thing. Um, so how have we actually implemented some of these technologies? So again, if you look at a coin, specifically a £1 or a £2, UK coin, you see that each of these coins basically have like a very specific writing on their rims, and it's actually really hard to be able to read those as well, right? But because it's hard to read, it's also very hard to kind of manufacture as well, because from a mechanical perspective, it's a very complicated process to have these sort of engravings on the rim, right? So what we have been able to do based on our technology is to actually be able to use the camera in such a manner that we are able to actually completely identify the actual imaging and the finishing and the writing of the rim, and be able to tell, like, whether it's a fake or a genuine coin. And even if it's a genuine coin, if there are certain issues with the production line, then we are essentially able to identify those as well. Now, previously, something like this would have required, like, multiple cameras to be able to set up. But we've been able to do this with a single camera, which obviously results in a much more cheaper alternative for our customers as well. Okay. One other implementation is specifically on the vials, where, again, the vials, when you think about it, you can inspect it in, like, so many different ways. But having cameras in, across the entire profile can be very expensive. So we've kind of, like, used mirrors to be able to look at the vials in its entirety and be able to identify any sort of issues. So again, you see that, using mirrors, we've been able to create these different profiles of the vial top, and you're essentially able to see a defect, and based on the defect or the algorithm that identifies the defect, you can essentially reject um, the uh, the defective product as well. Okay. So in conclusion, again, I mean, we've taken a very quick look into the world of, like, 3D computer vision, obviously with the emphasis on quality control and process improvement, because that's where our core competency lies. Obviously, there are much wider applications and technical details associated with this that go much further than the current presentation. But again, we've kind of, like, seen these improvements have definitely helped our customers, not only from an efficiency perspective, but also from, like, a costing perspective as well, where with limited resources they are able to do a much more thorough check and test on their side. So with that, I'm going to open up the Q&A round. Yeah, and I'll hand it over to Uni.
Brilliant. Thanks, Piyush. Even a few minutes early, which is great. More time for Q&A. And I think it's worth giving a big shout out. I can see Toby O'Mara and Tris from STEM here. I think Toby's tried to make the last 3 webinars and never made it. So thank you for joining us today. It's probably worth saying that, some of the work presented in thanks to our collaboration with them as well. So great for that. Given I can see the video feed from Belgium seems to have been pretty robust and live. I think maybe one of the questions I posed to Anu and Sudeep is, some of the images that we saw there of the coins and the vials, looking at seen around the coin or mirror-like views of the vial top. The question I would be asking them is, for some of the people on the call, what's the objective, or what's the value add of that compared to just having 3 or 4 cameras looking at it from different angles, because I'd imagine that might be easier to set up.
Hey, hi Uni. Hi everyone. Thanks for webinar 4 and nice to see everybody. Sorry, I can't take off my mask here, but just to touch upon the question that Yoni asked, synchronization of cameras can be quite a challenging thing. So suppose you have an application or a product that needs inspection at the exact same moment without the product turning or without losing some information. I can certainly tell you that with the sports applications, even a second you would have, say, a movement of your joint that is so far ahead, you might lose some information, and that's the same principle as well. So there are a lot of benefits of getting 3D data at the same time and same point with the products, because you might lose a defect that is not shown at the exact same moment, and simultaneous inspection is definitely worthwhile.
If anyone's got any questions, feel free to put it in the chat, or feel free to put your hand up, and you can do that virtually at the bottom of the GoToMeeting. There's a hand icon. Feel free to press that, and you can then come on and actually ask some questions or challenges that you may be facing where you think 3D might help, or just generally how could a vision system help.
Uni, while we are getting questions from others, I think one of the most things, and this can be a question with the money world as well. We get a lot of requests for 3D inspection on the money world, and certainly the image with the rim is has been a challenge. I mean, do you want to shed some light on that very quickly?
Yeah, sure. I mean, in a way, actually, that's something we worked with STEM on. I think Piyush touched on this in the presentation. You know, a lot of the counterfeit coins that end up at the bank or elsewhere. Sometimes it's very difficult or challenging to separate them from the good coins. But the rim certainly is the right place to do that imaging for the counterfeits. And actually, if you think practically, to pick up a coin and look all the way around it is quite a time-consuming task. So, you know, by being able to image it in line at speed, it is quite a big advantage. So, a couple of questions from Tristan. Do you use blue laser light on blister inspection? And the second question is, do you ever have issues with laser speckle in the red on the shiny foils? Obviously, some of the foils are very shiny. Annie, do you want to take that one?
Yeah, so it's a combination. Again, it's mostly the red laser line that works the best, and the blue works really well with the on metals and metal surfaces, whereas with the tablets, the red seems to be much better. You see a more variation of tablet colors to be of a lighter format rather than, you don't normally see a dark color tablets are quite rare, but then uh, the laser line color does make a difference, and there are specific materials and colors uh, that are that would be the decision making process of choosing the laser line.
Yeah, and it's worth noting for those of you that don't remember your wavelengths, you know, that I think maybe the reason Tristan is asking that is, you know, the blue laser light does have a slightly shorter wavelength. So if absolute accuracy in measurement is vital, then maybe you would lean towards the blue laser. I think the downside is those lasers are maybe slightly more costly than the red. And as a consequence, the red has, or certainly historically, been more prevalent in use. So it's easy to get hold of them and so forth. But actually, maybe we're not the right people to go into such depth. But thanks, Tristan, for those. Cool. Anu, anything to say? I suggest we leave it there for today and go again next month.
Yes, so Tristan has another question on the stereo application. What techniques do you use for reliable timing and synchronization of image capture? It's a really good question, Tristan, and you know that there are additional modules called as PTP, very, very useful. This is I think very few companies get timing correctly, and it's a combination of the right hardware, the right ways to trigger using software or hardware between the cameras, and for sure, third-party libraries cannot give you the synchronization required for a fast application. So it's usually on an embedded platform or C++, and those are kind of languages that can really help you interface in a very quick way to get synchronization correctly. But it's also PTP and other hardware devices that would help you.
Brilliant. Tristan, thank you for firing plenty of questions to us today. I'm glad you joined. And hopefully people have got some useful nuggets of information on going from 2D to 3D on the production line. I think it's fair to say that we've been using 3D in all the domains that we work with. So pharma, money, sport, and I know there's a few more obscure sectors that we delve into as well. So I suggest we leave it there for today. Thank you to those who have been able to join us. I know the Vision Conference in Germany has probably caused the competition for this, and so we look forward to seeing you hopefully next month or in the future. And feel free to reach out to us at any time. Take care, everyone. Have a great evening. Bye bye.